This is the video for section 11.2, day 2, chords. Please follow along with your video worksheet. The first section has all the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. Our first statement says if a radius bisects a chord, then it is perpendicular to the chord. And a second one says if a radius is perpendicular to a chord, then it bisects the chord. Now, these two statements are converses of each other. The first one says if a radius bisects a chord, so that tells you if your radius cuts your chord into two congruent segments, segment DB and segment EB. So if that's true, then we know that the radius is perpendicular to the chord. Now our second statement, like I said, is just the converse of that. It tells you if your radius is perpendicular to a chord, in other words you have the red right angle box, then we know that it bisects a chord, so you can mark the blue dashes on the two pieces of the segment. This brings us to our first example problem. We are given this picture and we're asked to find DC, AB, and AC. Now, first of all, we know from the statements we just talked about that since our chord is bisected, we know that that radius is perpendicular to the chord. So we have a little right angle box in there. Then what we're going to see is a Pythagorean theorem situation. We have a squared plus b squared equals c squared. So in this case, 9 squared plus 12 squared equals c squared. 9 squared is 81. 12 squared is 144 equals c squared. 81 plus 144 is 225 is c squared. Square root of both sides, and c, my hypotenuse, is going to be 15. Now, that is this segment right here, DC. So DC here is 15. Next, when we look at that chord AC, we notice that it's bisected. So if this piece is 12, we know that this piece is also 12. So that tells me AB is 12. And lastly, they ask for AC, which is the length of the entire chord, which is 12 plus 12, or 24. Moving on to our second example, what we're noticing here is we don't see a right triangle. So what we have to do is we have to take this radius right here, EF, and we notice, well, if that radius is 17, every radius of the entire circle is going to be 17. So we have to actually draw one in. And since they do ask me to find FG, I'm just going to draw in that one, which is FG. Now again, since EF is 17, I know GF is also 17. And then we can set up a Pythagorean theorem. We notice that 8 squared plus b squared equals 17 squared. 8 squared is 64 plus b squared equals 289. Subtracting 64 on both sides, we get b squared equals 225. And taking a square root of each side, we get that b is 15. Now that is this piece right here, which is GH. So GH is 15. And we noticed before that FG is 17. And GI, which is this entire length, is going to be 15 plus another 15, because if the chord and the radius are perpendicular, then we know that the chord is bisected, so I know HI is also 15, and together GI is 15 plus 15, or 30. Question 3 says find the length of a chord that is 7 meters from the center of a circle with a radius of 25 meters. So we're going to start out here by drawing ourselves a circle to work off of. And we're going to be actually constructing things that look very similar to what you saw in the last two diagrams. Okay, it says find the length of a chord that is 7 meters from the center of the circle. So here is a chord, here is our center, and it says my chord is 7 meters from the center of the circle. And it also tells me my radius is 5. So drawing in here, the radius is 25. Then we are going to be finding the length of the entire chord. So the first thing I'm going to find here is this little piece, which is going to be B. So I'm going to say 7 squared plus B squared equals 25 squared. 7 squared is 49 plus B squared equals 25 squared, which is 625. We subtract 49 from both sides. I get B squared is 576. And then we take a square root of both sides and we get B is 24. But that's not what they're asking for. They want the length of the chord. Now this is a real important thing here. They want the whole chord. They didn't want just that little B segment. So the whole chord is this whole thing, which is 24 and 24, which is 48. So 48 is what they're looking for, which is the length of the chord. Moving on to question 4, it says suppose a radius of a circle is 34 units long and a chord is 60 units long. Find the distance from the center of the circle to the chord. And again, we have to start by making a circle. Then we have to draw a chord and a radius going to that chord. And it says the radius of a circle is 34 units long, so we need an entire radius here, which is 34, and a chord is 60 units long, so that means this entire thing is 60. But we know that when a radius meets a chord, they meet at a 90-degree angle, and that also bisects the chord, so that this piece is 30 and this piece is also 30. And they want the distance from the center of the circle to the chord, which is this piece right here. Now that is one of the legs of my right triangle, so I'm going to be calling that A. So A squared plus 30 squared equals 34 squared. A squared plus 900 equals 1156. Subtracting 900 from both sides, we get A squared equals 256. And taking a square root to solve, I get A equals 16. So that tells me this little piece is 16. So they want the distance from the center of the circle to the chord, which is 16. This concludes the video on section 11.2 day 2 chords. Thanks for watching.